So, you're thinking about becoming an AI engineer. You've seen the titles, the salaries, the hype. It looks like the center of everything, like the people building the future are already there. And now you're wondering if you should step in too. You imagine building intelligent systems, models that see, models that talk, models that understand. It feels like stepping into the control room of modern software. But what you see from the outside is not what the work actually looks like. Because most of the time, it's not futuristic. It's not cinematic. It's not glamorous. It's Python scripts, broken data sets, long training runs, and models that fail in ways that make no sense. So in the next few minutes, you will see what being an AI engineer actually is. Not the fantasy, not the marketing version, the real sequence, step by step. At its core, an AI engineer builds systems that learn from data, systems that can recognize patterns, generate text, detect signals, make predictions. You're not writing fixed logic, you're building systems that derive logic from examples, which means your real job starts with data, not models. Data, you load it, inspect it, clean it, fix missing values, fix broken formats, fix human mistakes. Most datasets are messy, inconsistent, and incomplete. This is where most time goes, not building models. Preparing reality so a model can survive inside it, because if your data is broken, your model is already broken. Then comes the model. Maybe a neural network, maybe gradient boosting, maybe something simple. You define it, train it, and wait minutes, hours, sometimes longer. Training finishes. You check accuracy. Sometimes it's decent, sometimes it's useless. Sometimes it predicts the same answer for everything, and now you have to figure out why. So you adjust parameters, change features, retrain, repeat. This loop happens again, and again, and again. This is the real workflow. Iteration under uncertainty. And all of this runs on infrastructure, GPUs, memory, containers, cloud instances. You write Docker configs, monitor usage, watch costs. Because training models is not just math, it's systems engineering. Which brings us to skills. First, programming. Python is not optional. It is the operating system of this field. You need to load data, transform data, train models, debug failures. Second, math. Linear algebra, statistics, optimization, not theory for exams, but theory to understand why your model fails. Because without that, you're just guessing. And here's the part nobody tells you. Most models fail. Most experiments fail. Progress is slow, sometimes painfully slow. Improvements come in small increments. But when it works, it feels different. Because you didn't just write instructions, you built a system that learned. And that's the real shift. You stop being someone who writes logic and become someone who builds systems that discover it. So should you become an AI engineer? Only if you're willing to work through uncertainty, through failure, through confusion, because this field rewards persistence more than talent. And eventually, you understand the truth most beginners miss. It's not about using the most complex model, it's about understanding the system, the data, the constraints, and making them work together. Because in the end, AI engineering is not about building intelligence. It's about building systems that survive reality.